Welcome back! By now, you have gained considerable insight into the topic green hydrogen, its production, storage and transport. In this lesson, we will examine how hydrogen can be used in industry, with a particular focus on the iron and steel industry. Hydrogen is increasingly recognized as a key enabler of industrial decarbonization, offering a sustainable alternative to fossil fuels in sectors that are hard to electrify. However, given the cost and challenges of scaling up hydrogen production, it is essential to prioritize its use in order to maximize the impact. Apart from using hydrogen as a chemical feedstock, iron and steel production is a hard to otherwise debate sector, and therefore has to be prioritized and merits further examination. By the end of this lesson, you will have a comprehensive understanding of the scientific principles of traditional and novel hydrogen-based steelmaking, the advantages and challenges hydrogen-based steelmaking offers, and its contribution to the global decarbonization initiative. Steel is an indispensable material in our society. The construction sector, in particular, relies heavily on steel, and steel will also be an integral part for the energy transition, with solar panels, wind turbines, dams, and electric vehicles, all requiring steel in varying degrees. Global demand for steel continues to rise in line with economic growth, urbanization, increased consumption, and the buildup of infrastructure. Among heavy industries, the iron and steel sector ranks first when it comes to CO2 emissions and second when it comes to energy consumption. Steel production accounts for 8 to 9% of global CO2 emissions. These are about 3.6 gigatons per year. On average, the production of 1 ton of steel results in the emission of approximately 1.85 tons of CO2. Let us have a look at steelmaking now. The principal inputs today are iron ore, energy, mainly coal, natural gas and electricity, limestone, and steel scrap. Iron ore and scrap are used to provide the iron-bearing charge. Energy inputs are used to provide heat to melt the metallic input, and in the case of iron ore, to chemically reduce it. Primary steel production refers to the production which uses iron ore as main source of metallic input. The most used iron ores for pig iron production are iron oxides, mainly hematite. The blast furnace process, followed by the Linz-Donawitz basic oxygen steelmaking process, is used for about 2/3 of global steel production, making it the dominant steelmaking method in the world. This traditional method is known as the blast furnace basic oxygen furnace process. It relies on coke as fuel and reducing agent, which leads to the emission of large amounts of CO2. It is evident that CO2 emissions in the iron and steel industry must be reduced, with the ultimate goal of achieving net zero production. While new steelmaking processes are critical, it is also important to recognize that, up to now, there is not one right answer. It seems that a combination of approaches, including bioenergy and direct electrification, carbon capture, usage and storage, and hydrogen, could help achieve emission reduction in steelmaking. So what we need is a broad portfolio of technological options which can be deployed alone or in combination, as local circumstances permit. Now the question arises, green steel, can it work? And what role does hydrogen play green hydrogen can replace coke as the reducing agent. It reacts with the iron ore in a so-called hydrogen-based direct reduction process. By replacing carbon, the process becomes much cleaner, emitting only water vapor instead of CO2. Direct reduction is defined as a process in which metallic iron is produced by the reduction of iron ore at temperatures below the iron melting point. In other words, without melting. The product of this process is called direct reduced iron. Using carbonate iron ore, siderite ore, as raw material for steel making adds another exciting dimension to the hydrogen-based direct reduction process. This ore is used in regions with large deposits, such as Austria. Its iron content is lower, and processing is more elaborate due to the carbonate character. Processing of siderite contributes to further CO2 emissions due to the release of CO2 from the carbonate. Hydrogen-based direct reduction allows to circumvent the conventional two-step route of roasting for CO2 release and consecutive reduction in the blast furnace, as elemental iron is formed directly from the iron carbonate in one process step, even at relatively moderate temperatures of 700 to 800 degrees Celsius. In addition, the process gas is upgraded by the formation of methane and carbon monoxide instead of simply releasing CO2 into the atmosphere. The main benefits of using green hydrogen in steel production are evident. Green hydrogen can cut steel production emissions. The hydrogen-based direct reduction process produces water vapor instead of CO2 and thus eliminates a main source of industrial greenhouse gases. Renewable energy can be used to make hydrogen in an efficient way. This hydrogen can be used to make steel in a way that uses less energy than traditional methods. Green hydrogen supports a circular and sustainable economy, where renewable energy sources power both hydrogen production and steel manufacturing. Moreover, integration of green hydrogen presents opportunities for novel and innovative processes in steelmaking. While the potential is promising, there are still several challenges to overcome. Currently, green hydrogen is more expensive than conventional hydrogen, and the amounts required in the iron and steel industry are huge. A widespread transition to green hydrogen will require significant investment in hydrogen production, storage, and transportation infrastructure. Scaling up hydrogen supply chain is crucial to making the technology viable on an industrial scale. Although the direct reduction of iron using hydrogen has been demonstrated, further advancements in technology may be necessary to prove the economic and technical feasibility of the process. Furthermore, production of green hydrogen depends on the availability of renewable energy. Summing up, we can say that by adopting hydrogen-based direct reduction processes, the steel industry could significantly reduce its carbon footprint, while contributing to a more sustainable global economy. Although challenges remain, hydrogen represents a transformative opportunity for the future of steel production. So, keep learning and stay engaged with the exciting transition to cleaner industries.